So I was thinking about ways in which you can input data for our cubic spline interpolator, and it occurred to me that sometimes you don't necessarily care what the exact data values are, you just want to get a general shape. So I've created a new program that you can click inside the window here, and it will add data points for you wherever you click. So each one of these green dots I am clicking. I can even go back and click in gaps that I left behind before. I can even introduce little errors in the data maybe. And what I want to be able to do is have this data now fit with a cubic spline like we saw in the last video. So let me show you how this part works, and then we'll move on to the cubic spline. So what I first do is I create this done button. This is the red button in the lower right hand corner. We're going to click that whenever we are finished. And here I've got our data list. So this is just like we had before. This is going to be X, Y. This is our experimental data. This is going to be all of those green dots that I just created. Well, it's going to be the locations of the green dots. The green dots themselves are going to be stored in data marks. And then here basically what we're doing is waiting for a click. So in order to have this screen interaction, we have to use this scene.waitFor command. This basically tells the program to pause until the user clicks somewhere in that window, somewhere in this 3D VPython display window. And it's going to wait particularly for a click. It's not going to move on a keyboard press. It's not going to move on a right click or a middle button click or a double click or anything. It's going to move on a click, on a left mouse button click. And then it's going to record the location of that click by recording the location of the mouse at that moment. See, after we get done with wait for, it's going to move on to the rest of this. And here it's going to check for whether we've clicked on the done button. And so basically we're looking for whether this location is inside the range of the done button. So done button has a position. We're going out to the right by its radius, over to the left by its radius, up by its radius, down by its radius. So basically if all of these are true, if we're within the hitbox, then it will move on to the next part where we move on to working with the data. Otherwise, if we didn't click inside the done button, then we come over here and we add that point to our list of data. So here we have the point that we clicked at. We're adding that point, X and Y, to our list of data. Again, this is the thing that gets processed by the cubic spline interpolator. And then here we're creating the sphere. I'm adding it to a list of data marks. I don't currently do anything with this list, so it's not really necessary, but I might do something with it in the future. And so this big while loop starting at line 15 is going to repeat over and over again until we click in the done button, and then we'll set done equal to true, and then we'll move on to the next part. So then we move on to the part where we sort the data. Here is the link where I got this sorting code from. And basically what we're doing is taking our list of data and we're sorting it in order of increasing X value. That's why we're checking here for data element I with the 0th component. So that's going to be the first part, this location.x. And basically, as long as the one before is greater than the one after, we're going to keep swapping until we get them all in order. And we need these to be in order for our cubic spline code. So the cubic spline code assumes that all our data is sorted going from left to right. And then we come down here, and this is where I've pasted the cubic spline code. This is pretty much exactly what we had before. I made just a couple of edits on the display option, but this is basically everything we have from before. I'm having it find out what the xmin and xmax are for our display. And then I come down here, here's our make spline code that does all the linear algebra for us, just like before. Here we extract the coefficients, just like before. The only thing that's different is this time around, we're making our spline in our graph like we had before, but I'm also going to make the spline in the three-dimensional window, which I actually had to exit out of during a cut. So sorry about that. So we'll recreate our data curve. And then basically we use the curve function here to create the spline in 3D. All right, so let's hit Control-2 to run this. And so I click anywhere to add my data point. So let's click inside the window here. Let's give this thing a few maxes and mins, shall we? There we go. And let's give it one more maximum here at the end. All right, cool. So all of these have now been added to my list of data, all these X and Y coordinates. So I click on the button to finish. It goes through my sort, and then it puts in the cubic spline. I gave it a pretty wild function. It's got a pretty wild spline here. So here's the spline in the 3D space. I mean, the spline itself is not 3D because it's all in the XY plane. But it gives it a pretty cool look. It puts it here in the VPython display window. And so it's giving me my maxes and mins wherever I had a turnaround. And then down, I didn't expect to get max and min there. That's interesting. And then down here we've got the graph like we had usual, and we can do, a little bit better analysis here with our cursor and everything. But anyway, I thought this was neat. So if you're still having trouble understanding the way that cubic splines work, this is kind of a good way to get an intuitive feel because you're not worried about putting in the actual numerical values of the data points. You can just click to create the data points you want, and it will then fit it with the spline. So enjoy this, have some fun with it. Let me know what you think. If you've got suggestions for improvements, please let me know in the comments below. As always, thank you so much for watching. I will see you next time. Bye-bye.